All right, people, welcome back. So today we're dealing with a new problem of this new section, sliding window. This problem is called longest substring without repeating characters. So it's a medium problem. Let's see what we are able to do. So the explanation, the description of the problem is very simple. Given a string S, find the length of the longest substring without duplicate characters. What's the definition of a substring? A substring is a contiguous, non-empty sequence of characters within a string. So it's what I wanted to understand if it's composed by contiguous letters, and that's true. So for example, string S may be equal to A, B, C, D, E, A, and of course the longest subsequence is A, B, C, D, A, and that's it. Like everything except for the last E. Okay, so for example, if S is ABC, ABC, BB, the longest subsequence is ABC, yeah, with the length of 3. But the output must be the length. So in this example, for example, we need to return 5. Okay. So in this, if the input is B, 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 the output is 1, of course. And if the input is P, double V, double V, key E, double V, so it's this, I think it's a longest substring, yes, because the output is 3. So how can we approach this? Let me think just a couple of seconds. Okay, here is my idea. We define a set, okay? Then in this set, which has the property of being unique, we scan all the letters in the sequence and we see if the letters are in the set. If you find one letter, for example, this A, which is in the set, you stop, you set the set to an empty set again, you set like a counter to 0, and you update what you can call a max length, which is basically the maximum between the current length and the max length before. And then you return the max length at the end of the iteration. That's what I thought. So let's see if this is reasonable. So we define, let's call, okay, so S is our string, so we need to define a set. Let's call it I don't know how to call it. Okay, let's call it letters. So letters is an empty set, and now we want to scan in our string. So let's say for letter in S, if letter is not in letters, we add letter to letters. We can do something like letters dot add letter. Then what we can do if instead letter is actually in letters, we can define current length as basically the length of letters, and then of course we want to update the maximum length, which of course I think should be set at 0. Yes, I think so. So the maximum length is 0. Now the maximum length is gonna be the maximum between my maximum length and my current length. And then I set letters to an empty dictionary. And then that's it, I think. Of course, what happens if we go outside of the for loop? We may actually want to do this just one last time, because what happens if we have actually, like, the last letter is in the set, yeah, so we want this to be also outside of the for loop. Something that comes to my mind is that, yeah, I think this should work. Oh yeah, because for him this is basically a dictionary. Okay. Yeah, so I think we can write down set like this, and should work anyway. The output is null. Oh, that's because we are returning nothing. Return maximum length. Okay, so the first case is correct. The second case is correct. The third case, the output is 4, but the expected is 3. Why? P double V. Then you stop. You go to double V. Key E double V. But a double V, you shouldn't count. Oh, that's because here, letters, is updated as a dictionary again. Let me try now. Oh no, still doesn't work. Why? I think at this point letters must be letter. I don't know how it's possible that even though there were so many mistakes, the results are still correct in the first two cases, while in case 3 is still incorrect, which seems very strange to me. Let's see. Okay, you know what? Let's follow this string through the pipeline. So for letter in S, so let's start with P. If letter is in letters, which is not, letter is added to letters, yeah. So now P is in there. Now, second letter, double V gets in there. It's third letter, double V. Letter is in letter. So we go to else. The current length of letters is P double V, so it's 2. The maximum length gets updated to 2, and letters get updated to double V. Then you go to key, so you get double V key. Then you get to E, so you get to double V key E. The maximum length is then you go to double V, and so the maximum length should be 3. And letters should be to letter. The current length is the length of letters. The maximum length, I don't know why the result is 4. I don't know really. I'm thinking a bit. That's because letter is actually like I'm not asking if it's in letters. I'm saying if it is different. My god, that's super stupid. That's super stupid. Okay, and now it works. Now it works, which is fantastic. Let's try to submit it then to see if it works. But we've got some wrong answers. For example, for D, V, D, F, the output is 2 while the expected is 3. VDF. I see the problem. Because we expect, like here, when we update letters to letter, that's because we are implicitly saying that there is a duplicate letter like close to the new letter, while instead now there is a V in the middle. So we should actually initialize the set as all the letters before D. But how do we do that? Okay. Okay. So I think that to find the solution for this, we need to go back to what this section is about, sliding window. So I think here, instead of initializing letters from scratch, we need actually to imagine a window that is moving, and it moves until the letter is not in letters. Okay. So Maybe we need a while loop, something like while letter not in letters. And then we have something like while letter is not in letters, we remove from the set letters, like the letters dot remove, and then we remove. We need the counter. Like the idea is to remove the one which is at the left the most. So we need like a count. Let's call it left, and then we remove letters. No, let's remove s left, and then left plus equal 1, and then at the end letter is in letters. So we can, outside of the while loop, we can do letters add letter, which actually means that we don't need this if statement at all. We can do something like this. We can delete this, we can move. So the current length is this, the maximum length is this. Then we do the while loop in case we need to move the window, and then we add the letter. At the end, we define the current length. I don't know if this works. Okay, runtime error, let's see. Key error A. What's the problem here? Executed ABC. No, of course, while letter is in letters. Of course. And it works, guys. Sometimes, guys, the code works, but I don't really understand why it does. I just try things and they work. Sometimes I'm like 100% sure that a code will work and then it doesn't work. Okay, so let's see if this code can be optimized a bit. So we have a set letters, we have a maximum length, and we have a counter left. Then we scan each letter in S. We define the current length and the maximum length. Should we do that here or after? Well, in the first case, letter will not be in letters, so the while loop will be skipped. So I think it's good to put it there, so that these two like repetitions are not necessary. So after the while loop, the current length is updated and the maximum length is updated. So let's think about the time complexity. Space complexity is 01, surely. No, actually, no, not really, because if all the letters are unique, then you will end up with a space complexity of ON, to be honest. And the time complexity instead is, so we scan for every letter in S, and then we scan while letter is in letters. But what's the worst case scenario here? So if letter is in letters, the worst case scenario is like N. Yeah, I think so. Yeah, maybe N, even though it's not exactly like that, but yes, let's suppose it's N. So this is gonna be N squared, which is not great actually. Let me think a bit if it is N squared or not, because I'm not 100% sure. Probably, I am thinking that this can be actually ON, like the algorithm, because we are going through the letters, then we are doing this while loop through the letters. But of course, since every time we go through the while loop, we move of like 1 in the counter, the while loop will be basically composed of at most n iterations. And also the for loop will be at most of n iterations. So it's going to be O2n. So it's ON actually. Yeah, I think so. Okay, guys, I think we did a great job. So thank you very much for watching this video and see you in the next episode. Bye bye, guys.